M is this 3 by 3 matrix, and we're asked to find the inverse, giving each element an exact form. Look, this is only a couple of marks. It's absolutely fine to just put this in your calculator. In fact, you should be doing that to save time later on. So I've got this class-wiz version at this point it's writing. It's actually not the newest version, but it still does the job. Okay, yours might be slightly different. So we go to matrix, and then make it matrix A, 3 rows, 3 columns. Just got to type it in. So have a go at doing this as well. Okay, just check it over. Looks good. Right, we're ready to do the calculation. So matrix calculation, and then option. I want to select matrix A. It's a little bit clunky, it's got to be said. There are graphical calculators that can do it much quicker. Okay, actually, I don't do that. I go to -1 here, and that will find me my inverse. We get quite an awkward bunch of numbers, but actually they're all over 69. So what I'm going to do is, to save a bit of time, just take out 1 over 69 and then write out the rest of the matrix. And it ends up being 1, 13, 5, -11, -5, 14, -26, 7, and 8. In B, we're asked to solve these simultaneous equations. So let's write it as I mean, it should really say hence, but yeah, we can use part A to help us. Let's write it as a matrix system. And you can see we're going to have x, y, z here. So we're going to get 2x, and then we need a 1 here and a -3. It's the same matrix. 4, -2, 1, 3, 5, -2. Just check it is the same, but yeah, it is. And that is then equal to -4, 9, 5. So then x, y, z is going to equal, well, this is we can multiply both sides by the inverse matrix. Okay, because this will become the identity matrix. We'll just be left with the inverse multiplied by -495, the inverse being what we found a minute ago. So time to calculate, I'll put in another matrix. So define matrix, I'll call it B. This time it's got 3 rows, but only 1 column. -4, 9, 5. Now back to matrix calculations, and I want to do matrix A multiply, wait, not matrix A, the inverse of multiplied by matrix B. We get nice whole numbers. I'm pretty confident with that. So 2, 1, 3. Would be fine to leave it like that, but it doesn't say anywhere in the question that it's like a matrix or a vector or anything. So I'm just going to write down x equals 2, y equals 1, z equals 3. Brilliant. This is a single point. We're asked to interpret this answer geometrically. So you've got to realize that each of these is actually a plane. And we're looking at where they intersect. We get a single point of intersection, and essentially that is it. Okay, so it looks something like this. It is the intersection points of 3 planes.